Hi guys, Mr. Johnny here. It's been a while since I made some real video about some electronics, so I decided to show you what I'm working on right now. A little bit of what you would call a workshop update. Linoleum is gone. I went and painted the floorboards. Previously the linoleum was laid on top of the raw wood. Now the wood is nice. I took the floorboards out, put them on the sun. In the sunshine. Or on the sunshine, I don't know. Whatever. You got the idea. Basically, they're all nice and dry. I prepped them with some linseed oil. Then I painted them. They're now nailed into place. Linoleum will be put back in its place, on its whatever. Linoleum will be put back here once the winter comes. Basically, I want it to be here when there will be snow outside, because inevitably I'll be walking in and out of the shack and I'll bring some snow, and I don't want it melting right here and basically trapping some moisture here. It's pointless. Alright, what I'm working on right now, as you can see, it's a complete mess. Nothing new here really. I have this piece, which is a charger. Also a charger. That's a beefy charger. That's a charging starting device. Basically, that's a charger which has a mode to a sort of engine start assistant. It can't really start an engine by itself without the battery. The battery has to be there, but it's incredibly helpful, say in the winter time when your battery is not the best and you can't really start the engine just with the battery. You hook this on and it will assist the battery in starting the engine. The front panel contains an on-off switch, which is really a breaker. Power on indicator means it has an ammeter here up to 10 amps. This indicator basically shows up that you're connected right in the engine start mode, and you have a little knob here to control the charging current. Inside there is a beefy transformer. You can see how big is it. You can see two beefy SCRs here. Nice big thyristors. 50 amp rated. They are on this heatsink. Common node of these SCRs is the heatsink, and it also serves as the negative output of this charger. On the back we have 5 terminals. This one is positive output. It's common for both modes, battery charge and engine start. These two are connected together, and that's your negative for output for the battery charging mode. If these two are connected together, that's your negative for the engine start mode. The positive output is common for both. Basically what this thing is typical old stuff, which uses a phase fired controller, which is on this board right here, which controls these SCRs. Basically you choose when in the half cycles to turn on the SCRs, and you control the average power like that. Okie dokie, what I've done here to make it work again, I changed this capacitor, which was bad, and I replaced this LED, because the LED which was there is incredibly dim. It's a very old technology. This one that I installed is not a super bright LED either, but it's still brighter than this one. So the complaint was that it wouldn't work in engine start mode, it just worked in engine in car battery charge mode. And I don't believe this capacitor was the cause. The cause was basically that the owner did not really understand how to use it. Because this thing has protections. Without the battery, it outputs absolutely nothing on the output. It has absolutely nothing on the output in both modes. It has to see some voltage. This way it's short-circuit proof. Well, up until the point when you connect the battery to it. But then you'll be shorting out the battery as well, so that's your problem, really. And yeah, it has, I believe, reverse polarity protection and short circuit protection, which I already explained how that works. Basically, without the proper polarity on the outputs, this thing does not turn on these SCRs. That's it. That's really what was the problem with it. Because they probably went and connected it up to battery terminals and they had no battery there, and of course it wouldn't work. This thing again is not capable of starting an engine by itself. It's really an assistant. If you have a weak battery, you hook it onto that and it will help that weak battery to start an engine. Ain't nothing wrong here. Okie dokie. What else? I have some projects in the background. One of them is this iron, which I plan to use for soldering, which is really kinda nice because basically I will use this as a hot plate that I can use for numbers of things. I can use that to preheat the screens to aid in removal. I can use that to solder aluminum based boards, copper clad aluminum boards, which I used in LED lights and such. It is very easy to solder to work on these boards, on this kind of thing. You just put the board on top, you set about 250 degrees. You do not have to set it high, that's the beauty of it. You just set 250 degrees around there. Even with lead-free solder, it works extremely well. I do have some experience, that's how I can tell, because I have repaired quite a few items like that. It works fantastic. So here is just a little thermostat, which sensor is a thermocouple with an M6 thread, which looks something like this. It's really an industrial thermocouple, K-type. I have that basically fed into the thermocouple amplifier using LM358. Another op-amp in that package is used as a comparator, and that controls triac on this heatsink. That's it, nothing fancy. This is temporary on off, basically indicator to show me that it's on or off. That works good. I'm gonna make a separate video about that later. What else do I have in background? A CDI ignition right there. That's here. How it differs from the typical CDI ignition is that it uses MOSFETs instead of SCRs. This thing is really a multi-spark ignition. It can deliver multiple sparks within one pack, It's just gonna be a bunch of sparks at once. So that should basically overcome the disadvantage of the CDI system, and that is a very short duration of the spark. So that's that. Another thing that I already done actually is this little buck converter, which is designed to be connected to 24 volt supply. It can use anything from 15 to 30 volts DC, of course, and it outputs around 13.9 volts, somewhere there. This thing is a battery charger for motorcycle batteries, for stuff like that. And it has some neat features like reverse polarity protection and short circuit protection, bada bada bada. I'm gonna make a video about that as well. If you want the video to be made quicker, leave some feedback that you really want or you really need this kind of design. You will benefit from it, and that will motivate me to actually speed up this process. So that's that so far. And yeah, my old phone died. It was a Samsung J7. I'm really disappointed lately with the Samsung phones. After 1 year approximately, they start to be sluggish as hell and very uncomfortable to use. That's why I changed the phone. Now I'm using Xiaomi phone, Redmi Note 7. That's what I'm shooting this video on. It can actually shoot in 1080p, 60 frames per second, but my internet connection is not really fast enough to upload that kind of videos, so I will stick to 720p, 30 frames per second for a while. Maybe once in a while I will upload some Full HD videos in 60 frames per second. So that's basically that. What else? Oh, I do have another stuff. I do have this LCD TV to repair. It's a Samsung TV. Which I don't even know what's wrong with it, because the chap brought it to me and I asked, what is wrong with it? He said, I don't know, I've been given this TV to basically get it to you. I'm like, oh well. Alright, so that's that. 13 minutes of babble, fantastic. So I will try to upload some more videos about those specific topics. Again, you can motivate me down in the comment section. Thanks for watching. See ya.